Hello everyone, so today we are going to discuss the problem of the day for the Geeks for Geeks. Intersection point in Y-shaped linked lists. So, in this question, we're given two single linked lists. Return the point where the two lists intersect. So, there are two lists that has been given to us. So in both of the lists, there are nodes that are common in both of them. As you can see, these two nodes are common in both the lists. This list includes these nodes and this list also include these two nodes. Okay, so we have to basically return the first node that's common between both the list. So how do we approach this problem? So we will be given two heads of the list. Yeah, there's a head 1 and there's a head 2, isn't it? So what we can basically do is use hashing in this kind of problem. So we can choose any of the two heads. We start with head 1, okay, and we can traverse along the list. This is our head 1 and this is our head 2, okay. So first we choose head 1 and we traverse along the list, and as we traverse along the list we keep on storing the nodes, okay. So we traverse, we store this node, we traverse, we store this node, then we move to the next, we store this node as well, then we move to the next, we store this node, and then we store this node. So all these nodes are stored in a hash map, okay, or in a set, okay. So the set basically will contain the path of head 1. Now we choose head 2, okay, and then we start traversing along the list again. So as we traverse along, what we will do is for every node, we'll check whether that particular node has already been visited, okay. We will check whether the particular node has already been visited. So we start from over here, okay, we check this node is basically present in our set. Well, we have never visited this node, so it will obviously not be present in our set. If we come across this one, we will check in our set whether this node has been previously visited, and we will get to see that this node is there already present in our set, and hence we will say this particular node is the common node among both the linked lists. Let's move ahead and code this up. So these are the two heads, head 1 and head 2, that's given to us, okay. So let's traverse the head 1 first. So we will assign the iterator to head 1 and we will traverse over it. While current is not null, we'll do current is equals to current of next, isn't it? And as we traverse, we will be storing these nodes in a hash map or in a set. So let's create a set of node, okay, let's call it SD. And since the order doesn't really matter, so let's just create an unordered set, okay. And let's be storing these nodes in the set. So we will insert these nodes in the set. So st.insert the current value of the node, okay. So we basically have traversed over the head 1, isn't it? Okay, now let's just set this current to our second node head, okay, and let's traverse the path of the second head, okay. Now if I come across any node st.count this particular node, if is not equals to 0, it means it has already been visited, and the first node to show that property, the first node to show that it has already been visited is the common node, okay. Then we're going to return that this is the common node, isn't it? So we will return its value because this is what the question has asked us, okay. And if we don't find any, we'll just do current is equals to current of next. And if the linked lists are in the Y shape, we are sure to find this particular value, right? Now at the end of the code, obviously we know that this condition must have met before. You can return anything because this line will never be executed. So let's just return -1. Let's run the code and see if it works. Okay, let's try and submit it. As you can see, we have successfully submitted this code. Now let's try and see the other approach of doing this problem. Now that we have been able to solve this problem using an extra space, the space complexity of our code would be the O of the total number of nodes, right? Because we are storing every nodes, and in the worst case scenario, we can be storing every node that's present. So how do we avoid that space? Can we eliminate this space, and can we do it without using any space. So if we give a thought, let's take an example. So if we see this particular example, in this example, let this be our head 1 and let this node be our head 2. Okay, and let's say we have our head 1 and head 2 and we move together. Okay, if we move together, the head 1 comes here and the head 2 comes here, and if we move again, the head 1 comes here and the head 2 as well comes here, and this is our going to be the common node, isn't it? This is our common node, and we approach this particular common node at the same time. And why was this possible? This was possible because the head 1 and the head 2 were the same distance from this common node, isn't it? And after the common node, every other node that comes is common for both the linked list, right? These nodes are common for both the linked list, isn't it? So if the length of both the linked lists are same, if the length of both the linked lists are same, can we simply traverse together, right? We can simply traverse together and can find the node that comes first and can find the node that is common in both of them and that comes first, and that is going to be our answer. But what if the length of both the linked lists are not the same? So what if there's an extra node over here? So instead of this being the head, this is our head. Okay, so now if we traverse together, so if we start from here and we start from here, we go head 1 equals head 1 of next, so we get here, and from here to here we get here, right? Now again we traverse, then we get till here, and if we traverse over here we get here, two different nodes. So there's a problem. So if we need to get to this particular node at the same time, we must start from here, isn't it? So what we need to be doing is we need to be first doing head 1 equals to head 1 of next. Okay, and then we need to travel together, and as they travel together and the first time they meet is going to be first common point. Now if there is one more node, to it, then we have to be doing head 1 is equals to head 1 of next 2 times, right? We have to be doing it 2 times so that we start from here, right? And head 2 is already here, and we move together to get to the common point, right? So who decides how many times we should be doing this? Well, the difference in the length decides that. As we kept on adding the nodes, we needed this operation. If we added one node to head 1, one extra node, we needed this operation 1 time. If I added one more node, we needed this operation 1 more time, right? So we needed 2 more operations if we added this node as well. Okay, so the number of extra nodes that are there in one of the list is the number of times we need to perform this operation to the larger list. Yeah, and then we should start traversing together. Okay, so our approach is going to be, we first compute the length of list 1, right? Let's call it length 1. Okay, and then we compute the length of the list 2. Okay, let's call it the length 2. Now after computing the lengths, we need to decide which one is bigger. Okay, so let's say we will assume that len 1 is bigger, and in case the len 2 is bigger than len 1, we're just gonna swap the values. And we have to swap the list as well. So we are saying that if both the lists are not of the same length, then the first list is the bigger one. Okay, this is what we are saying. Okay, so by how much is it bigger? We need to find out the difference, right? So let's compute the difference, and we need to be doing this operation how many times? We need to be doing this operation difference number of time. So let's just make a copy of it. Okay, and we have to do this operation difference number of time. Okay, as we do this, if we take this example, we need to be doing this operation 2 times, right? Then our head 1 is over here, isn't it? The head 1 would be here, and the head 2 is already here, the smaller list. And then we need to be traveling together. If we travel together in both the list, then the first node that comes up in both the list is going to be our answer, right? So after doing this operation, we need to be traveling along both the list, isn't it? So while head 1 is not null and while head 2 is not null, okay, we need to be doing head 1 is equals to head 1 of next, and we need to be doing head 2 is equals to head 2 of next. So we travel together, right? And if in any case we observe that the nodes are same, so if head 1 is the same as head 2, we return the value of the node. Okay, And that's how our code logic is going to work. So now let's move ahead and code this up. Let's start by removing our previous code. Okay. So first of all, we need to compute the length of both the lists. So let's let it be computed in len1 and len2. So let's compute the length of the first list. So we assign a temporary node to the head and we traverse. As we traverse, we increment the count of our length and we do current equals to current of next. Now after length 1 is calculated, we calculate the length 2. So we set our current to our head 2 now. Okay, and then we traverse again. Okay, and as we traverse, we increment our length 2 and we do current equals to current of next. Okay, now we said that the longer list is going to be our list 1. Okay, so if in case our length 2 becomes bigger than the length 1, it means the second list is bigger than the first. We basically just swap the two lists. Okay, we just swap the lists. Okay, so we just swap the head 1 and the head 2. Okay, and we also swap the lengths. Okay, and now we find the difference. Okay, so difference is going to be the bigger one minus the smaller one. Okay, now for both the lists to get to the common node at the same time, we need to perform difference number of operation in the bigger list, right? So we need to perform diff number of operation, right? And in this operation, what do? We change our bigger list to a node so that the bigger list and the smaller list both reach the common node at the same time, isn't it? And now we finally write the code where we move together both in the bigger list and the small list. So while head is not null and while head 2 is not null, okay, we do head 1 equals to head 1 of next and head 2 equals head 2 of next. Okay, and if a case occurs where head 1 and head 2 is the same, it means we have reached our common node. So we return the value of that node. Okay, and finally we can simply return -1. Now let's run our code and see if it works. Okay, it is working. Let's submit it. As you can see, we have solved this question without the use of any space. Our space complexity is going to be just O of 1. I think that's it for today. Thank you.